part of the HPC team in Ghent. So part of the team who's organizing the dev room today. And he's going to introduce EasyBuild.
I already got a very good introduction to the people who saw the previous talk about environment modules. People who are not familiar to the team, we're from Ghent University, high performance computing team. It's a central contact for high performance computing at Ghent University. So we have big computing infrastructure, 7 clusters at the moment, and one shared system between the Flemish universities. Top tier 1 was number 119 in top 500 in 2012. There's 8 people in the team, they're all here today. So, yeah, one big part of work at our team is to install the scientific software for scientists. They want to do simulations, they want to do their research, and they need the software to run in the cluster. They can't install it themselves. They ask us to do this. And of course, one of the models is automate everything. So we have 7 clusters. We're not going to install manually the software on each cluster again and again. We automate the build procedure. And so EasyBuild grew out of need for this. As in the previous talk, Aaron explained, building scientific software is really fun for us. Very good documentation. Everything works flawlessly, of course. No, not the case. Yeah, as he said, it's written for people who need it to work for themselves. They use hard-coded settings, like their fonts are all hard-coded. So if you want to use the environment modules, as we saw earlier, you have to patch here, because you expect these libraries to be a non-found, then you need to use the environment. It's what we set up. So it's very time-consuming, also for other HPC teams. And the tools that were available are lacking. So we prefer to build everything from source. So the installation is not just downloading the RPM and installing it. It's high performance computing, so you want to use, with a CPU, you want to use all the instructions. It has to compile for your CPU. And to do that for scientific software, you say, yeah, use Gentoo. Well, almost none of the packages that these researchers want are already in there, so you have to do it yourself anyway. And then why restrict yourself to one operating system? So they're hard to, there are tools out there. Other institutes that made just a list of bash scripts. They just run it with bash, 10,000 of lines, not really maintainable. Or just standalone, start a new thing every time, but they don't try to reuse anything. Or very OS dependent, as I said, ports. And some projects, they know they're really hard to install, like Dolphin. They have a tool called Dorsal, which is again bash scripts, no reuse. Well, some good news, it works, but only for software. It's really hard to add everything to it. So, as I said, yeah, not all of them are packaged. And just, yeah, make an RPM, yes, but then the other distros, people use another environment, you have to redo the work again. Also, yeah, like current tools, current OS is really hard to install multiple versions of the program, because this is often a big requirement. Researchers all use the same system. Researcher A wants version 1.0. Researcher 2 found out there's new features in 1.2, so if he wants to use that one, they all both have to be available in the system. And we compile them with different compilers. We compile with Intel compiler, GCC, CLang, because sometimes different compilers give different results, or we want to test which one generates the most performance code, and leave it there. For example, we would build with everything with Intel, because mostly that's the best performance, but GCC, the researchers also want to use the same thing they have on their laptop, and then they compile it with GCC. So we want to make both available. say you can switch KPI stacks, change the master kernels. So what we wanted was a flexible framework. So we wanted other people to be able to join us in the effort and add features easily. So had to be flexible, modular, pluggable. So a big part of this, reproducible builds, because the scientists, they need to be able to reproduce their experiments. So if they can build it in one cluster, but then the system is gone after 3 years, or they want to do a little thing again, well, they try to make install the same version of the software and all its dependencies in the same version. Already explained coexistence of different versions. A big deal is also the sharing of the effort. So we put a lot of effort in it, and we want to share it with other teams all over the world. Because if we share it with them, hopefully they share back, and in the future maybe we can easily install something without having to do much effort. Of course, everything has to be fully automated, and dependency resolution as we install dependencies. So we don't want to build everything one by one. We just say build this and all its dependencies. So that's what EasyBuild does. It's written in Python, so people can use it because we like Python. We use it for all our tools. EasyBuild has been developed in-house for 2.5 years before we made it public. It was completely rewritten with good practices in mind and released as open source in 2012. Then we finally got the state API in November. And since then we're doing semi-monthly releases, not monthly. And we're working on this continuously because our users keep requesting us to install software. Other teams are requesting me to add features. So we try to release frequently. It's available again. We have various contributors who contribute to EasyBuild, so mostly HPC teams and other universities or institutes. Also people from NVIDIA helped us with the NVIDIA support. They're running it on their own test clusters. We don't have GPUs ourselves, but they try to run it, and there's also other people on site doing it. So how does it work? We distribute EasyBuild and what we call easy configs, so what we know as recipes. Call it the .db file. So this is the previous commando, then you give it the file -r to do recursive build all the time. So what does this file contains? It contains the name of the software, where it can be downloaded, short description, version, list of its dependencies, and what toolchain you want to build it with. So if you run this command after installing EasyBuild, this will try to download all the sources it can find. Maybe some mirrors are down or something, or you don't have internet, you can just put the sources in for applications or pick them up. So this will build first, download the version of GCC and compile GCC from source again because we want it to be reproducible. So we know it was compiled with this version of GCC. So every build we're going to do, we're going to use the same version of GCC. So start with building that one, then all the dependencies, the toolchain. And once they are available in your system, as EasyBuild will see the module is available, so it won't build it again the next time it needs it. So it will generate the module files that we saw in the previous talk for all of these packages automatically, so you don't have to write your module files yourself. The dependencies will be in there. You just do module load HPL and everything will be loaded and available. The build process then goes through several steps. It should make perfect sense. If you want to install the software, we try to add extra sanity checks so we make sure the installation was correct and the files are recorded. Do clean up. So what are the features of EasyBuild? Other features, logging. The entire build process is logged and the log is saved next to the installation. So if 2 months from now you notice something is really bad, maybe something different, you can still go to the log and see maybe something did go wrong there, or what version, what environment. people try to be very helpful. They ask you, they give you just one binary. Sometimes it's closed source programs as well. They just give you binary and ask you questions. There's no way to patch it when you're around it. You have to actually answer the questions. We have support for that. And replies. Since we have a huge cluster, we have lots of machines to build. So if we have commission a new system, we can just run one command -- job, and we'll use our cluster's scheduling software to push all, to build a dependency tree. Once that dependency is correct, we push all software to the new cluster, start the builds. We can, 48 hours later, all the software that was available on the old system is now available on the new system. And we try to do comprehensive testing, so we have unit tests, and before every release of EasyBuild, we use the job and we build all the software we know of, we build it to see if it still works as expected. Currently, what we released, 443 packages are in our public Git repository with over 3,000 easy configs, so with a lot of different versions, a lot of different toolchains. This includes a few very hard to build software packages. If you have to install them yourself, you will know that. Over here last year as well, I made a list of all the packages that were in there. Then it was readable. There were about 150, so in 1 year time, we added another 300. So if you're interested in how the modules, how the software is designed for this, so we have the EasyBuild is split into 3 parts. We have the framework, which forms the core of EasyBuild. It provides all of the core functionality, like the commands for patching or pushing to Git. All of this is implemented in the framework. Then we have easy blocks. So some software, there's the recipe, but just the download URL and the version is not enough, because by default you configure make install. But of course, not all the software uses this. It would be very good, of course. So an easy block is something you specify to do instead of configure make install. This is pure Python module. So this is where you implement the entire build. So instead of documenting it, this can be generic, like for a Python package. First you install Python, and you want to install matplotlib. Then you know how Python packages work. You set up .py. More software specific, so for just one specific software. It's Python, it's object oriented, so usually you only have to implement 1 or 2 functions and not an entire build procedure, just use code that is already there. And then there's the easy config file, which we call the recipe. Currently there are still text files in Python, but this will change in a new version. So as I said, modular design, dynamically extensible. So if you add easy blocks, you don't have to put them somewhere on the right space or load them. Put them in the Python path in the right module, and EasyBuild will pick it up. So as I explained, you can have generic easy blocks, application specifics. So the framework has some tools to do the interactive commands, unpacking files, applying patches. And there's tool chains, so tool chain consists of the compiler and the API command kernel. This allows us to pack the feature in one place and then build an entire software stack with these tools. So we have one for Intel, we have one for GCC, there's one for GCC with CUDA, and so on. So you can pick match and create your own tool chain. Of course, it also generates the module files, which is really awesome. If you already have module files and you want to reuse them, maybe you have a different naming scheme, so you can just configure everything. This was added quite recently. We test everything. If you're planning to use it, please also test things if you have new packages first. So you have been working hard on actually doing good software. practices who actually use it. But we still need something we do need is better test for the software. So we install the package, but we're not really sure if it's doing what the researcher wants us to do. We ask them to give us an example, but that doesn't always come. There's also no problems with environment module setting LD library path. If you have a lot of dependencies, this becomes big and might strain your storage system if it has to go through all the directories. So there's solutions for that RPath. These are being investigated. Okay, maybe I convinced you, you want to use it. Well, what do you need? Linux. It will work we test this on Fedora, Debian, CentOS, SLES. So we have a developer using it on a daily basis on OS 10. We have no Windows support planned. This is because there's no environment modules for Windows, so you can't use it. It's not because we can't. By 2.4, so we're running this on some old systems that still have 5.2.4 and fully supported for now. Not sure for how long, but for now, everything will be written by 2.4. And a C compiler to start your first build of GCC for the Intel. Installing EasyBuild, well, there's a bootstrap. We'll look into providing RPMs and deb files soon, because that's maybe the easiest way to actually get it installed. But you can install EasyBuild with EasyBuild. You can find all of this on our wiki. Configure it as much as you like. You might try to make it very easy to make your changes. So, if you want to know more, we have a website, we're on GitHub. You can download it from Wi-Fi. We're very active on IRC, channel EasyBuild on Freenode. Follow us on Twitter. Questions you can also mail us. Questions?
All right, Ian? I have 2 or 3 minutes for questions.
One package you mentioned was open for. I tried to build performance and I couldn't get it to build. One of the things I didn't like was it ships with a specific version of GCC, but you say you do that. I understand why you do that. Can you say a little bit more about that, why you do that? I didn't like that. I thought, well, it shows the software is rubbish, you know, it needs a set version of GCC. Whoa.
No, so we do this so we can reproduce the build. So we built it with this version of GCC. Later on, the researcher wants to do this on his laptop. He wants to try the same build, maybe a different version has different features or does something else, so he can actually reproduce the build with the same version. But basically, yeah, we build GCC once, and then it'll be used forever. It'll be on your system, so you don't have to rebuild it every time. So you install it once. If a new version of GCC comes out, you can rebuild all your packages with the newest version, and leave the old ones in place, so the researchers don't get paranoid. Everything just changed, and you leave the old one, and the new version of GCC comes out, you can rebuild it for the people who want to. That's the reason.
I have similar use cases. I've researchers come to use my systems, and they want the latest GCC, but people using our system in production they won't change it. You know, I convert. There's a mechanism in SUSE Linux for putting in extra compilers and extras or something like that. You put it somewhere else in the this sounds even better.
Yeah.
So, if a researcher is creating their own software to run on our machine, should I be recommending to them to create their own EasyBuild modules for their package?
A few of our users have actually done this. They can ask us to install software, we do it, but if they say here is the EasyBuild tool, it works in EasyBuild, I've added it, then we'll just install it.
A lot of them are working on several different systems, including the National Tier 1 machines as well as that one. Because I'm recommending CMake external project for that kind of thing in a lot of cases, and I'm wondering if that would be a better EasyBuild routine.
Choice, yeah, so not really that about CMake. But we wrap around CMake, so if they use CMake, by default we configure make install, but if there's a project already using CMake, just wrap around it and also call the CMake. Everything still works.
when the sources are stored, it's like anywhere, or if there's
So you,
the repository. Well, when you run all the sources for the application,
yes,
some of them might be some obscure old code, right?
exactly. So this is one of the known problems. Sources can be removed from the web. There are some efforts to actually start the sources that we're allowed to distribute, to collect them somewhere on the mirror. There's a project being talked about.
What is external from this? It's just like
Yeah, that's a separate problem. We're not trying to solve.
Is this presentation also on your website?
An alternate version of it.
We have a YouTube video as well.
Just on the archiving sources thing, a certain scientific package, which will not be named, changed the sources without changing the version number, just quietly changed it online.
There are several ones that do.
And so that's why in the new version we added actually checksum.
Is there
One more question?
is there some sort of repository for the EasyBuild files?
Yes, so they're on a GitHub.
So when you pull the file, you pull the dependencies of the EasyBuild file, or?
So currently these are just easy config, so you pull all of them in. They just plain text files, a few lines.
So you also maintain the local copy of all the EasyBuild configs?
At the moment, yes.
It just gets installed with EasyBuild. So EasyBuild is a framework, the easy blocks, so the implementations of the build procedure, and then the specifications of the.
So we call these examples. So they're known to work, and we try to share them with everyone, but they're considered examples. You can make as many as you want. And if they work, please share them with us.
Okay, last one.
Sorry, Peter. Intersecting with another big theme at Fosdem, you're packaging up a file tree and practical modules. Could you make a Docker container out of this? That'd be the next step. I'm talking about code.
I'm sure you probably could, yes, but we're not going to do that.
Well, I haven't looked into it yet, but it's just like basically an RPM or that.
Well, you can make a Docker of the applications and ship that and keep it for archaeology, keep it for this version works.
We've been looking into these Docker people, talk to them, but not really.
Okay, that's it. Thank you very much, Jens.